Hi guys, so today we are going to look at how to find out whether something is oxidized or reduced. Now there's a few rules that I use when I'm doing this. Number one is I just list what is split and what is not. So Fe is a solid, it's fixed in position, the particles are bonded together through metallic bonding, so it doesn't split, and so therefore we can just write Fe like so. But the CuSO4 here, copper sulfate, is aqueous. Now aqueous means it's a substance dissolved in water. So here we've got a system whereby now we've got a splitting taking place. In water, the copper sulfate splits into ions. So we have Cu2 plus and SO4 2 minus. Okay, and similarly, if we put that arrow next to it, Cu is a solid, and this is also a metal. It's fixed, it doesn't split, it stays as Cu, so we're going to keep this as Cu. FeSO4, however, iron sulfate, is going to split, and it does so, and so we have two ions here. Now there are some ions you need to remember in your GCSE. Sulfate is one of them. We don't know what iron is because it's a transition metal, so it can have variable oxidation states. So let's use something that's more permanent, which is the sulfate ion. Now, the sulfate ion is a charge of SO4 2 minus. So therefore, to balance this 2 minus charge, we need to put a Fe2 plus, like so. So now we've got all of our ions split and all the metals in our equation. This is also actually a displacement reaction. Okay, and if you see over here, the iron is being is going to displace the copper in this reaction, and so iron is more reactive, it's higher up in the reactivity series. Copper will be displaced, and so copper is now by itself and iron is produced. This is also an example of a redox reaction, and we'll show you why. A redox basically means one species is oxidized, the other is reduced. Right, so at this stage, we've got to the first part, we've split the ions. The second stage now is to make sure that we know what are the spectator ions. Now this, dependent on what GCSE course you're doing, is necessary or not necessary. So I'm doing this stage because I think it's really important to kind of understand the process. So the sulfate ions on both sides, okay, are the same. Therefore, they are not taking part in the reaction. When that happens, we call them spectator ions. Now that means they're spectators, they do not take part in the reaction, and so we can just literally cancel them out. Now what's left over here is two different ions. Okay, we have an ion atom, which is Fe, and we have its constituent ion, which is Fe2 plus. So I want you to bring the like atoms or ions together, so Fe and Fe2 plus. So let's do that. So Fe arrow Fe2 plus, and the other like terms are your copper 2 plus and copper, which is Cu2 plus arrow Cu. Right, so we've nearly done our half equations. Now in this example, we need to find out what is oxidized and what is reduced. Now there's more than one way of doing this, but the rules that I'm going to teach you is, if it's oxidized, keep your electrons on the right hand side. So Fe2 plus and Fe here. Now from going from Fe, which is a neutral atom, it's now become a positively charged ion. When this happens, that positive charge is a result of electrons being lost. A 2 plus charge on the right hand side means there must be a 2 minus charge to balance the right hand side as well. So we've lost 2 electrons, so we're going to add those 2 electrons. Let me do that in yellow. Keep it all consistent. So we've got 2 electrons added. This is lost because it's on the right hand side, and it's also balanced because you've got 2 electrons over here and 2 positive charges. So we've made sure that we've ticked all of those boxes. Now in copper 2 plus and Cu, to go from copper 2 plus to Cu, you need to add electrons. And let's just make this a little bit more nicer looking. So I'm going to add the arrow here a little bit so I can make some more space for the electrons. Now over here we're going to add our 2 electrons. Okay, and that's 2 electrons because there's a Cu2 plus there. So now we've got our 2 half equations. This one is gaining electrons, which is copper 2 plus. So therefore, if it gains electrons, let's use our acronym oil rig. Reduction is gain. So therefore, this is a reduction. And we can say that copper is reduced from 2 plus to a 0. Similarly, our iron has been oxidized. Okay, so iron is oxidized. And so we have it going from 0, which is the atom, to a 2 plus charge. Okay, now this part over here is more A-level when you talk about oxidation states, so don't worry too much about that. What you need to know is why it's oxidized and why it's reduced. If it's reduced, keep your electrons on the left-hand side, making sure that you add electrons to your ion. If it's oxidized, keep your electrons on the right-hand side, and it's going to be lost because there's an ion on the right-hand side too. All right, brilliant. So you can also make this an ionic equation. So all you have to do there is you take the 2 half equations that you've made in yellow and purple, and you combine them. Now, what's easier about this is that you have electrons that are being lost over here, and they're being gained by the copper on the other side. So in effect, these 2 cancel out, because if they're being lost on one side, they're being gained by another. And so what you're left with now is your right hand side. If I circle these together, so on your right hand, also your left hand side, I beg your pardon, you have your Fe and your Cu2 plus. So let's put that down, Fe plus Cu2 plus, and that becomes whatever's on the right hand side. So let's put these 2 together. Oh, that's a nice little blue colour, isn't it? Okay, so let's do that, and these 2 become Fe2 plus Cu. And there you have it, guys. There is your ionic equation. Now if you want to, you can add state symbols, but the idea here is to understand that we're just combining them afterwards, and we now know what is oxidized and what is reduced. Thank you for listening.